Hey everybody, it's finally here. We are at trigonometry. So what we're going to do, there's a lot of points here. We're actually only going to talk about the first one for today, and then we'll gradually move into the others then as we go into the other lessons. So the first thing is, what is trigonometry? And in Greek, it just means triangle measure. And specifically, it is going to be then the relationships between angles and lengths in triangles. We will most commonly use this with right triangles. I've looked ahead. I don't think we're going to get into the trigonometry that involves non-right triangles, but this is going to be our main focus. In IM 3, there is going to be a chapter in Term 3 where you do talk about non-right triangles, but for this, we're mainly just going to focus then on the right triangle. So the first thing, in order to do trigonometry with a triangle, is we have to label the sides of the triangle. So given an angle, we must label the opposite side, the adjacent side, and the hypotenuse. Now, the hypotenuse should be the easy one for you. You've already learned that from Pythagorean theorem. And so the hypotenuse is always across from the right angle. So we know then we can put an h there for the hypotenuse. Also, the hypotenuse is the longest side of the triangle, so that's another way that we can find that. Now, these are going to be two new things for us then, the opposite and then the adjacent. So we are supposed to be looking at this angle, and that that's a Greek letter there. It is called theta. We're going to be doing a lot with theta now. Theta is just pretty much what mathematicians use for the variable to represent an angle measure. To draw theta, usually what I do is I just draw kind of like an O or a 0, and then I just loop around. So you'll see me do it quickly, and I'll often draw it like that. That's pretty much all you need to do. I do know some people that like to do a 0 and then a line through it. It doesn't really matter. Just something that is circular and you've got something going through the middle is good enough. Okay, now we have to label the opposite and the adjacent sides. So the opposite is going to be the one that is opposite from where the angle is. So if theta is here at angle A, well then our opposite side is on the other side of the triangle right there. And then the last thing is the adjacent side, and adjacent is always going to be next to theta and the right angle. So adjacent to the right angle and to theta is where we will put A. And there we go. We have labeled the three sides of our triangle, the opposite, the adjacent, and the hypotenuse. Okay, now we need to do the same thing with the other triangles. So for letter B, actually I shouldn't have deleted that. I should just move that, because adjacent means next to. So once again, the hypotenuse is the longest side and it's across from the right angle. So there's our hypotenuse. The opposite side is on the other side of the triangle from where theta is. And then the last one, the adjacent side, adjacent is next to both theta and the 90-degree angle. So A is going to go down at the bottom. And then for our last one down here, letter C, hypotenuse is across from the right angle, opposite across from theta, and adjacent is next to theta and the right angle. So what I want you to do then is go ahead and label the sides in these two triangles. Take note of the letters, this one using theta at angle A, and this one is using theta at angle B. Pause the video, and then when you are done, I will show you what your answer should be. Okay, so the reason that I chose a question like this is when I taught this in other schools, students often struggled with knowing that the opposite and adjacent sides switch if theta switches. So for the first one, theta is there at angle A. So the hypotenuse across from the right angle, our adjacent side is going to be between the right angle and theta, and then the opposite side is across the triangle from where theta is located. So that's what we should have had. For the second triangle, though, theta now is at letter B. Our hypotenuse is going to stay in the same place, but this time the opposite and adjacent can't be on the same sides that they were before, because opposite from theta is this side over here, and then the adjacent side is supposed to be between or next to the two angles that we have, so that is the adjacent side. All right, now you might be familiar with the names of these, the trigonometric ratios. Now these are not all of them, but these are the ones I'm going to start with for right now. We have sine of theta, cosine of theta, and tangent of theta. And so just so you know, this is how you spell them: sine, cosine, and then tangent. And one important thing to note about tangent as well is that it actually is a ratio of the other two trig ratios. We can also write tangent as sine of theta over cosine of theta. So these two are always going to be equal to each other. And as we move further into trigonometry, not just in IM2, but in IM3 and then in calculus as well, that's going to be a very important thing to remember, is that tangent is equal to sine over cosine. By the way, all of these are ratios of side lengths. And as we move further into trigonometry, maybe not so much in this video, a little bit I guess, but as we get into like the next video and later in this week, you're going to, I'll be able to explain more of how these are ratios then for our triangles. Now we need to get into the other trig ratios, and these all happen to be the reciprocals of the first three that we talked about. So 1 over sine is going to get this right here. This is called cosecant. Then the second one, 1 over cosine, gets us to secant. And then the last one, 1 over tangent, is the same thing as cotangent. And we can also work backwards from those as well. So down here, you'll see as well, 1 over cosecant takes us back to sine. 1 over secant is going to be cosine, and 1 over cotangent is going to be tangent. And I'm not going to demonstrate with all three because it's very similar, but I will show with one of them. The reason for that, I'm just going to do cosecant. If we happen to have 1 over cosecant, then that's the same thing as 1 over sine. And then if we know that we have 1 over sine, then we can take that 1 in front and multiply by the reciprocal of the denominator. Instead of dividing by 1 over sine, we can multiply by just sine. And then 1 times sine will bring us to sine of theta. So that's why 1 over cosecant can be equal to sine theta, and why we also then get the same with those two down there. Now, I don't think I'm going to have to check what we have. Okay, we're not going to get to SOHCAHTOA quite yet. There's one other thing. A lot of people make this mistake, and so I think I'm going to actually just do it down here. People don't seem to remember which trig ratios pair with which ratios. So we're going to start with sine, cosine, and tangent. And over here, I am going to write cosecant, secant, and cotangent. And I'm going to show you the common mistake that people make. The mistake is that a lot of people think that sine goes with secant and that cosine goes with cosecant. And I'm going to write this especially big No. I just circled that secant and cosecant. No, you can't do that. Don't do that. Don't do that. Don't do that. Here's actually the way that you should remember the correct pairing for these. I want you to think of the beginning for each of these pairings. Sine and cosecant, then cosine and secant, then tangent and cotangent. Specifically, I'm going to write it in pink here. Cosecant has a co. Sine has no co. Cosine has a co. Secant has no co. And then the last one is super easy. Tangent, no co. Cotangent, co. And that's what I want you to use to remember the relationship between these. Sine goes with cosecant. Cosine goes with secant. Tangent goes with cotangent. And the no co and the co are the ways that you should remember that. So I might throw that into a later video. I'm not really sure yet, but I might throw that somewhere later just to help check to see if you have remembered how to pair these together. Okay, now we will get to SOHCAHTOA. SOHCAHTOA is probably the most important thing you will ever learn for trig. So the most important. It's an acronym that is going to help you remember your trig equations. So back from earlier, we were talking about the opposite side, the adjacent, and the hypotenuse for a triangle. SOHCAHTOA is now going to tell us how those relate to the trig ratios. So we're going to start, I'm going to write it down here again. And the reason I'm doing that is because I'm going to circle, or I guess maybe box, the first part, SOH. And the importance of SOH is that this tells us and I should draw a triangle here as well. There's theta, so you should be able to see there's the adjacent, there's the opposite, and here's the hypotenuse. So that tells us then that sine of theta is going to be equal to the opposite side over the hypotenuse. That is the first equation that you need to remember for trigonometry. The second equation is this one right here. And now that I've shown you the first, you probably can make a prediction of that second one. Cosine of theta is going to be the adjacent over the hypotenuse. So cosine, adjacent, hypotenuse. And now I'm going to have to move this triangle out of the way. I'm just going to move it down there for now. Oop, forgot that. And our last one, again, you can probably make a prediction what that says. Tangent of theta is going to be the opposite side over the adjacent. And that does make sense. Off to the side here, I'm just going to quickly do this. Because remember that tangent was sine of theta over cosine of theta. So that means then that we would have had opposite, and I'm going to get really lazy here, I'm just going to use single letters, opposite over hypotenuse, and then the denominator would have been adjacent over hypotenuse. The hypotenuse cancels in both, and you're left with O over A, just like there for tangent of theta, opposite over adjacent. So that takes care of the most common, the three most common trig ratios that you are going to see. However, this does exist then for cosecant, secant, and cotangent. Now we don't have a neat acronym to help you remember them, but that's why it was important earlier to remember the cos and no cos, because that's how we're going to figure out the other ratios. For our first one, cosecant Because cosecant is 1 over sine, that means then that we need to do 1 over the opposite over the hypotenuse. And that ends up being the reciprocal. Hypotenuse over opposite. So that's what we will use whenever we need to find cosecant. So to give myself more space, I'm going to erase these, and then I'm just going to move that over. Hypotenuse over opposite for cosecant. Then the next one is going to be secant. So that is the reciprocal for cosine. That one is going to be hypotenuse over adjacent. And then our last one, I'm trying to pick what color haven't I used yet. Let's do dark. No, let's do orange. Cotangent then will be equal to adjacent over hypotenuse. And I'm getting kind of close to that right triangle there, so I'm going to move that out of the way. Let's see, I'm going to move it. Oh, doesn't want to move. There we go. Move it here and then shrink it down a bit. Okay. There we go. So those are all of the trig ratios that we are going to need to remember. You have to remember all of these equations. They're going to be extremely important for this entire chapter. Okay, so for this example then, we are going to find the 6 trig ratios of angle A. And when it says 6 trig ratios, that just means you're supposed to find sine, whoop, I'm not writing this well. You're supposed to find sine, cosine, tangent, cosecant, secant, and cotangent. And again, kind of like I said earlier, trigonometry is relating angles to side lengths, and all of these here are going to be ratios of sides. So the very first thing we need to do, if we have angle A, we should put theta there. And then the next part is that we need to label the 3 sides of our triangle. Hypotenuse is easy, that's always the longest side. I'm going to fix that, it looks kind of like an A there. Hypotenuse. The adjacent is always going to be the one between the 2 angles that were given, theta and the right angle. And then the opposite is always going to be opposite from theta. Now that we have labeled the 3 parts of our triangle, we should go ahead and write out these ratios. We know sine is supposed to be, here, I'm going to write it down here as well. SOHCAHTOA. Sine is opposite over hypotenuse, according to SOHCAHTOA. So I am going to write the opposite number over, not the adjacent, over the hypotenuse. The problem is we don't know the hypotenuse yet, so we have to go and find that. So we talked about Pythagorean theorem a couple videos ago. This is going to be a Pythagorean triple, so some of you might already know what that missing side length is going to be. Otherwise, if you don't notice it, let's just go ahead and calculate it. We're going to get 25 plus 144 equals c squared. That's 169, and that is a perfect square. 13 is our hypotenuse. Now we can go ahead and find sine. It is 5 over 13. Now that we have our sine value, we can easily find cosecant. Because remember, cosecant is just the reciprocal of sine. So if sine is 5 over 13, cosecant is 13 over 5. And it's that easy. So let's go on to cosine now. From SOHCAHTOA, cosine is adjacent over hypotenuse. In our triangle, we have 12 and 13. And there we go. Secant is going to be very easy. It is just the reciprocal of what we found. That is going to be 13 over 12. And then the last one, we have to find tangent. Tangent is going to be the opposite over the adjacent. So in this picture, 5 over 12. And then cotangent is the reciprocal. That is going to be 12 over 5. Okay? What I want you to do here is the exact same triangle, but this time I am telling you theta is at C. So go ahead then and find the 6 trig ratios for this triangle. When you pause the video, and when you are done, I will give you the answers. Okay, now that you have tried this, so theta was going to be right there, so that means our hypotenuse is still in the same spot. However, this time, the opposite side is going to be down at 12, and the adjacent side is at 5. Now that we have labeled all the parts, we can go ahead and find our trig ratios. So sine, again from SOHCAHTOA, that is going to be the opposite over the hypotenuse. So that means that we're going to have 12 over, and we remember from the previous slide, we said the hypotenuse was 13. So that means that our opposite over hypotenuse, 12 over 13. Therefore, cosecant is the reciprocal, 13 over 12. Then, cosine is going to be adjacent over hypotenuse, 5 over 13. So therefore, secant is the reciprocal, 13 over 5. And then the last one that we have, tangent, is going to be opposite over adjacent. So that will give us 12 over 5. And therefore, the reciprocal of that is 5 over 12. So I included this because, once again, I just wanted you to know that our opposite and our adjacent sides are going to switch depending on where theta is in the triangle. Here we had A with 5 and O with 12, whereas in the other one, A is with 12 and O is with 5. Okay, so one more, just a little extra practice then. So again, try this on your own, pause the video, and then when you are done, you can check your work with my answers. Okay, so we are told that we are doing this from angle P, so I drew in theta there. We are also missing one of the sides of our right triangle. Once again, this is going to be a Pythagorean triple, so some of you have already noticed that it was going to be 3. Otherwise, if you didn't, you could have just done x squared plus 4 squared equals 5 squared. Then we get x squared equals 25 minus 16. X squared is 9, and therefore x is 3. So that's another way that you could have found that. Okay, now that we have that, then we're going to continue on with finding our ratios. So from SOHCAHTOA, starting with sine, we need to label our opposite, our adjacent, and our hypotenuse. So I'm noticing in this picture, theta is across from 3, so that's going to be the O. The adjacent is between the right angle and theta, so that's going to be 4. And then lastly, the hypotenuse, the easy part, is always across from the right angle, so that is going to be 5. Now we can go ahead and start labeling. So sine of P, opposite over hypotenuse, that is 3 over 5. And then cosecant has to be the reciprocal, that's 5 over 3. Cosine then is going to be adjacent over hypotenuse, 4 over 5 is that value. So then the reciprocal is our secant, 5 over 4. And then the last one is that we are going to have opposite over adjacent for tangent, which then causes cotangent to be the reciprocal 4/3. Now, I didn't include this as a slide, but it is one thing that I wanted to point out. Sine and cosine will always be less than 1. And the reason, if I go back up to this picture here, is that if you look, well, 5 is the hypotenuse. And we know that the hypotenuse has to be the longest leg in, or longest side in a triangle. So that means then that our other two sides always will be less, which means then that this fraction that we have, this fraction that we have right here will always be a fraction with the smaller number on top and the larger number on bottom. The same is going to be true for cosine. Meanwhile, for tangent, tangent is going to be something that is anything between 0 and infinity. And I'm going to go back to this one here. As an example, you could see tangent happened to be larger than 1, whereas sine and cosine still were less than 1. Now, we're not going to actually ever get close to infinity here, but just letting you know that tangent, it is possible for tangent to be larger than 1. So maybe what I could actually say as more accurate can be larger than 1. So that will be a good thing to remember then whenever you're trying to solve these, and if you want to check if your answer makes sense. Sine and cosine has to always be less than 1, whereas it is okay for tangent to be larger than 1. Alright, so we are through everything. Just letting you know, although this looks very small, just be aware that there are 2 parts to 1, and then 2 has like A through, I don't know, I think it went all the way up to J. But remember, on Schoology, I'll let you know what is required and what you are allowed to skip. Thank you for listening, everybody. Congratulations, you're at trigonometry now. Have a good